All right, this is the second part of the absolute value inequalities. We just went over inequalities that have the less than or less than or equal to sign. And we saw that it sets up a compound inequality where your solution set is contained by your two solutions. So now let's go over greater than or equal to absolute value inequalities. So here we have the absolute value of x is greater than 3. So what this is stating is that x must be more than 3 units away from 0. So this time, anything in here is less than 3 units away. But over here, all of those are greater than or more than 3 units away. And all of these right here are also more than 3 units away. And because I have greater than and not greater than or equal to, we get parentheses. For that to be a bracket, it would have to have that line under it, symboling or equal to. So in this one, when I write this in interval notation, notice that I have two separate sections of highlighted areas on this graph. So you have to talk about each highlighted portion individually. So over here, if this wasn't even here, how would we represent this portion here in interval notation? Well, this is forever going further and further to the left. So this is negative infinity. So we have negative infinity to 3 with a parenthesis. Okay, that is this portion here. So now I need to talk about this portion over here. This one now starts with a parenthesis at 3, and it is forever going to the right, which is positive infinity. And so it is going to positive infinity. Now, when you have two separate sections that are highlighted, okay, when there is a break in between your solution set, you're going to put a U in the middle, and this stands for union. Okay, so it's both of these portions here together. Okay, so then what are these as interval notation or as an inequality? This one right here is saying that x is pointing to negative infinity, so is less than negative 3, or because there's a break and because there's more than one answer, this portion over here is saying that x must be greater than 3. So when you have greater than, you have two separate highlighted portions on your graph, which means you have to represent your two highlighted portions in interval notation with the union in between, which means I have two separate inequalities with an or in the middle. That was not the case for less than. Less than, it was just one portion highlighted, which means one interval notation and a compound inequality. That's not true for greater than. So this is again the most basic inequality we can get. Let's now apply it to these down here. Remember, the first thing I need to do is isolate this absolute value. This is not isolated yet because it has a -1 with it. So let's first add this over, and we're going to get the absolute value of 5x is greater than 20. So now I have my absolute value portion isolated, and because it is greater than, I know I'm setting this up as two separate inequalities. Okay, the first one here is what's in your absolute value, take it out. So we've got 5x. We're flipping that symbol. So this is less than, and it's less than the opposite of your number. So less than -20, or 5x, and just keep your symbol and your number is greater than 20. So this one over here looks exactly like this without the absolute value. This first one here that I made, I flipped that symbol and I changed the sign. So now we can solve, and we're going to divide by 5. And we get x is less than -4. Okay, or divide by 5, and x is greater than 4. So when I graph this, I've got -4 and I've got 4. This one is pointing to the left. So we are going to the left, and we've got a parentheses because it's not or equal to. But over here at 4, it's greater than, it's going to the right. So I'm shading to the right, and it's parentheses again because it's not greater than or equal to. So in interval notation, you have to represent each of these shaded portions. This shaded portion here is forever going to the left, which is -infinity. And it's stopping at -4, which also gets a parenthesis because we have it here, because we don't have a line here. When I have two shaded portions, we got to put them together with a union and now represent this portion here. We have parentheses 4, and it is forever going to the right, which is going to infinity. Okay, our last example, my absolute value is already isolated for me. So I can go ahead and get my two equations. I know I'm going to have two equations here because this is greater than or equal to. And so I'm going to have my two sections. So the first one is 2 minus 3x. I'm going to flip this sign. And this one's going to become a -1. Or it's going to look just like this without the bars. 2 minus 3x is greater than or equal to 1. So solve, and you're going to solve both of them the same way, but on this one, we're going to subtract 2. I'm going to get -3x is less than or equal to -3. Divide by -3. And now x, because I'm dividing by a negative number, I've got to flip this symbol. It's greater than -3 divided by -3 is 1. Okay, or same two steps. Subtract your 2. I get -3x is greater than or equal to 1 minus 2 is -1. I'm going to divide by -3. Because I'm dividing by a negative, I'm going to flip this sign again and get 1/3. 1/3 because positive over positive. Or sorry, negative over negative. Goodness. Okay. So let's graph. I've got 1 and 1/3. For 1, it's pointing to the left. So we are shading to the left. And because it's or equal to with that line under it, we get a bracket. And then at 1/3, it is pointing to the left. So I am shading to the left. And it's going to be also a bracket because it's or equal to. So in interval notation, this portion here is forever going to the left. So that is negative infinity with a parenthesis. Infinity is always get parentheses. To 1/3 with a bracket. Because I have two separate things, I'm going to join them together with a union. Then this side over here, you've got bracket 1. It's forever going to the right, which is infinity. So infinity there. Make sure you understand the difference here between your less than and equal to absolute value inequalities and your greater than and greater than or equal to inequalities, because we set them up different and they look different.